Hi, everybody. Thanks for listening. I'm going to talk about some rather interesting neural network technology, and that's part of artificial intelligence, to do with looking at the semantic meaning in a document in open ends in this particular case, and seeing if we can use that as a sort of analysis technique. This was very much an experiment, the study I'm going to present now, but it does have some interesting potential, I think. And I feel it's a good example of how, how neural network technology and artificial intelligence could be used for market research in the future. So using these things called neural networks, and as very apropos, the previous speaker was talking about them, this is where you hear people talk about deep learning networks. The one that this one uses could be classified as a deep learning network. And these algorithms actually are quite interesting. Is they'll give us a numeric value for a word or a piece of text. And actually, it's not a single numeric value. It can be a list of numbers. And you can have anywhere from 10 to 400 numbers that you get out of this neural network, which defines a word. There's a whole long backstory about how it gets there, which we can't get into at the moment, but trust me, it gets there. And it'll also do this for a document. And a document is just a piece of text. And in our case, we're talking about open ends derived from a standard market research server. We can then use these numeric values to map out similarities in the meaning of these open ends and effectively develop automatically, and that's the key term, some sort of semantic mapping. This technique was invented in Google. It actually, when you read the paper, the author was actually quite surprised that it worked. And I think his supervisor, by all accounts, was as well. But it's an extremely powerful algorithm, and the basis of these algorithms, just to mention words, are called word to vec, and vec means vector, list of numbers, and document to vec, document to a list of numbers. And these are actually being used by Google now, I believe, in their search engines, and are turning up to be really quite powerful algorithms. So they're getting a lot of applications throughout text processing, and obviously when we get to text processing, we end up with market research. So the idea is that these algorithms can take a word, and words embody concepts, and reduce, if you like, the concept to numbers. So in my example here, I've got a baby, a cat, and a mom. Three pretty common items. And what the algorithm does, what you do is you give this neural network the word baby. It gives you back a list of numbers that it thinks represent baby according to how it's been trained. And you train these networks on just a lot of text. There are several chunks of text. There's one called the billion word corpus, which is the one I kind of use for this, which is really just a huge amount of text has been used, and we've got all these words. There are all these words. There are a billion words in there, not a billion unique words, but so we could look at the context of how the words are being used, and based on that context, it derives a list of numbers for it. So we get baby has a certain list of numbers. We get cat, which has another list of numbers, and we get mom, which has another list of numbers. And what we can do then, by just some clever little mathematical functions, is produce this sort of map. So we have baby in the middle, and if we compare baby to mom, we get a value of 0.6. And so this is saying that it's close in a way. That number is larger than any of the other numbers. So you can say that baby and mom are related and semantically similar in some way. They're at least very related. Dad's a bit further away from baby. Milk's still there. Milk and cat, quite interesting. Diaper is like dad. Horse, you would expect to be farther away semantically, because while horses have babies, they have foals, it's not the kind of thing that comes up in conversation when you're talking about a baby. And a rock is even further away, very distant in these terms. And again, when you think about it, when you talk about babies, rocks aren't a common topic of conversation. So this is what this system is doing. It's giving this kind of semantic map between entities, all derived from automatically just looking at text and the way the words are used. And the neural network gives us these values. So then what we can do a similar sort of thing with pieces of text. And here I've got, you know, in the middle, the cat sat on the mat. So very standard little sentence there. So how close are these other little sentences to it? Well, the baby sat pretty close at the top there. The baby stood a bit further away. The rock stands on the mat. Well, it's still standing and it's on a mat. The baby sat on the mat. Well, we know baby, you know, tends to come in the same semantic arena. So that's kind of close. And the baby standing a bit further than sat. So you can see how it's kind of mapping out these sentences according to their meaning. This is a very simple example. And of course, as you have pieces of text that are more and more complicated, you find the relationships get more and more complicated. But this is gives you an idea of the underlying theory of what we were going to do with these open-ended responses that came from a standard survey. So a little while back, Andy Dexter, who's a British researcher, pretty well known, did a survey about the reasons people gave for their vote in the British Brexit referendum, which was all about leaving the EU. And as you probably all recall, the result has caused a lot of consternation for people like me. And this was an attempt to try and understand, you know, what were people thinking about Brexit. And they're actually asked to give 3 reasons. You can find out more information about this. This is just one of the articles that have been published about Brexit. So there were 2014 completes. So I had 2014 open ends, and they were asked, as I said, for their top 3 reasons for their vote. And for this particular study, I kind of merged all those into a single sentence. I have done another one where I took them individually. It was just something I decided to do. So Andy very kindly allowed me to have the data, and I decided to run it through these neural network algorithms. And so for each open end, each document, I got a measure of it, and then I calculated how it sat between all the other ones. So I was mapping them out in a sort of space. I used a pretty standard statistical tool, cluster analysis. Nothing fancy about that. That's the kind of thing you come across. A lot of quants use it. It's nothing particularly fancy. To kind of then say, okay, given the way that there are all these documents defined in this space, they've all got a distance between them. How would a cluster analysis say they group together? So it's an attempt to map out, if you like, the semantic landscape of this group of texts automatically. I didn't go and encode anything. I didn't, you know, I didn't impose any sort of structure or meaning on them. I just sort of, you know, let the algorithm run, got the distances, ran the cluster analysis. And then based on those clusters, we can analyze them and see what's in them and actually see if it's given us any meaningful differences between the clusters. And this is actually a map of a previous run, but the maps turned out pretty much the same. So this gives you an idea in this sort of cluster analysis. It gives you this space. Now there's a group over there which was quite interesting, the top left-hand corner red ones. And then we have the other items which are sort of in a clump, but the clump's segmented. When you look at it, this thing's actually 3-dimensional. When you start rotating it, you can see that you can actually see that there are differences between the groups. So this, if you like, is the semantic map of the responses according to the neural network. This is how, with the cluster analysis, it sees them mapping out. This is a count of how many were in each cluster. And really, I wanted to be sure that we weren't just getting a sort of random allocation across the clusters. If it wasn't doing its job, if it wasn't finding any meaning or differences, these would probably all groups would have the same numbers in them. But as you can see, there are actually, you know, some wide differences in the groups. I can't remember, I think number 6 here is the kind of red bunch up at the corner, which actually turned out to be kind of junk, very clearly junk when you look at it. And there was another category, and it was number 2, which I didn't look at, which turned out to be very off-the-wall comments that really didn't appear to have any relation to Brexit and really any relation to what everybody else had said. And so they were kind of, you know, really very, very different. And it did pick these out. And what I did was I decided it would be interesting to look at the 3 major groups. That's group number 1, 3, and 4. These were the ones obviously here where the majority of the responses went. But still, there's a difference in the frequency of them. It wasn't like all these were equal. 1 to 3 to 4, we get an increasing number of respondents. So this is a sort of text analysis of the group. Now, if we look in the top right corner, this is an emotional analysis of the text in the group. There's a key there, so you can see that blue is trust, grey is disgust, and the others as we go down. The number in the middle says, according to this algorithm, the percentage of words in that group that were deemed to be of emotional content. So here we see there were 43%. In normal text, you would expect somewhere between 20 to 25. Once you're starting to get up to a level of 30% emotive, that's actually reasonably high. The dots just are showing, we're reflecting this so that, you know, there was, I think it's saying here, there was 20% that were negative, the red, and 29 were positive. This is an analysis here. We have an analysis of the adjectives that were used in that group, a standard kind of word cloud here showing that free came up a lot in that group. And this other top left one is showing phrases, what we called n-grams, groups of words. And these are actually sorted. So in order so that, you know, sometimes people use words in different combinations. So this is trying to, you know, zero in and make sure that immigration control and control immigration actually come out as the same phrase. And so we can see here that, you know, control immigration was very important in this group. Border control, free movement, it's managing to clump together things. So when you think about control immigration and free movement, those 2 phrases don't have any similarity in structure, but actually are semantically very meaningful in terms of, you know, how close they are together. So this was group number 1. We can then look at the next group. We have things like European, free, a bit less emotive if we look at this number. Again, lots of stuff about immigration, border control, control the country, human rights coming in, retain sovereignty, strong, free, European, British. Those are, again, a set of themes, particularly the European and British, which obviously being Britain, came in quite strongly when you actually read through the responses. So you can see that reflected. Then if we look here again, finally on group 4, less emotive, 29%. So we're getting down to where, you know, normal speech. And if you look at this, the interesting thing about this one is there's a lot of mention of EU in the phrases, in the what we call the bigrams. These are 2-word phrases. We can also look at 3- and 4-word phrases. But there's also a lot of mention of the word European. And of course, EU, European Union, and European actually are very similar in meaning, but of course structurally, again, there's 2 words. One's actually an acronym, it's not even a word. They have a similar meaning, and the analysis was able to bring out and say, well, yeah, these actually sort of mean this similar in meaning and should go in the same group. So I thought it was quite interesting when the idea of this was to give a sort of semantic analysis, that it did actually group things together that were semantically meaningful, but the structure, like, you know, 2 letters versus a word, were very different. And that's what we would hope if it was picking up on the semantic structure of all these open ends, rather than just doing a word comparison and saying, well, you know, they're pretty close in terms of words and spelling, maybe they mean the same thing, which very often, you know, is not actually true. So, summary. The analysis did manage to pick out sort of 0 responses and sort of, when I looked through the groups, responses that really had no meaning, and put them in their separate groups. You know, people had typed randomly in the keyboard, or they'd just given some bizarre open ends. As we know, respondents are given to giving out bizarre open ends, and it managed to put those together. It did pick out the main themes, and this allows us, you know, possibly to do an automated analysis of text that will look at the meaning. You know, there's a lot more work to be done on this, rather than the structure of the words. And the end point of all this is really to have a technique which summarizes for us text. The problem we now have, which is the reverse that we had, say, 25 years ago, is that we have a lot of this unstructured data, as one of the other speakers was saying, and we've got to try and put some structure on it, and we need tools to do it. You can't ask somebody to read through 10,000 open ends and give you a summary in 4 days' time of the themes and expect to get very coherent. And then when you get to 50,000 or 100, it simply isn't possible. And so we need to start developing, using AI, using automation, techniques that will help qualitative research do their analysis. This isn't trying to replace the qualitative research. It's just trying to provide them with the same level of tools that we have in quantitative research. So thanks for listening, and any questions?